Okay, this is 6.2. Again, formula progression arithmetic progression كلهم نفس الشيء. هكتب لكم formulas before we start. The first one, to find any number, like let's say I want the 17th term, you can apply this formula. This formula is an is the first term plus, because you know it's a progression, you keep on adding. So you start with the first term, you add a certain number to reach this number. A1, which is your first term, plus n minus 1 d. N minus 1 is yani, let's say for example I want the 18th term, it will be A18 equals A1 plus 18 minus 1 d. Let's say d is the difference, huh? D is difference, the constant difference. المهم, that's the first formula. The second formula, I have, let's say I want to subtract any two terms. It's an minus am equals n minus m d. Okay, like you just have to memorize. And then the sum, the formula for the sum of any, yani, let's say the first 17 numbers or 18 numbers, it will be n over 2 times a1 plus an. Moving on, I'll give you the formula for the sigma. We actually have a formula for the sigma. The sigma of any number, let's say k, okay, starting with 1, ending at n. You're probably gonna say it's just k times n. No, it's not. Okay, it's equal to n over 2 n plus 1. Okay, n over 2 n plus 1. These two formulas are actually similar. They're the same thing actually, but just in different meaning. Okay, why we got this is, let's say you have a progression. Okay, 1 plus 2 plus 3, because you know sigma means sum. Continue, then you go and it ends at n. What comes before n? N minus 1. What comes before n minus 1? N minus 2. The way actually we derived it is, they started adding, because you know if you add any two numbers it's the same thing. They're adding the first with the last. 1 plus n is n plus 1, right? Then 2 plus n minus 1 is again n plus 1. And then 3 plus n minus 2 is again n plus 1. And if you keep on going, you're gonna realize that it's always n plus 1. How many numbers are you multiplying by this n plus 1? It's actually n over 2 numbers. Why is it n over 2 numbers? Because you're taking two numbers at a time. If you just put n times n plus 1, that's wrong. It should be n over 2, since we're taking two couples at a time. This is actually the way mathematicians derived it, and I honestly didn't know why. No, I didn't even know what the formula was until I asked my mom, and it's the way they teach it in university. I just thought I'd let you know for the people who actually like understanding. I think that's enough. That's it for the formulas for this section. Let's start. Question 1. What's the sum of the first 20 terms? If its first term is 18 and its 20th term is 38. If they want the sum. What's the formula for the sum? It's S, the sum, is n over 2 a1 plus an. In this case, we want the first 20 terms, so it's going to be the sum of 20 equals n over 2, so 20 over 2 times a1, the first term, which is 18, plus the 20th term, a20, which is 38, and you put this on a calculator, you get 560. Question 2. The first two terms are 0 and 5. Define the next four terms. Okay, so like I said, the formula to find any number in an arithmetic progression is an equals a1 plus n minus 1 d. This was the formula. So the first term plus how many times you add in between. So let's say we want a3. It's going to be a3 equals a1 plus 3 minus 1 d. Okay, can we solve this? Yes, it's easy. A3, A1. What's the first term? 0. Plus 3 minus 1, 2. Times d. What's the difference between 0 and 5? You always take the final minus the initial. Please, nobody do 0 minus 5 equals negative 5, so the difference is negative 5. No, 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 no. It's always the number after. Okay, the number after minus the number before. 5 minus 0 is 5. You get A3 equals 2 times 5, which is 10. Okay, so I'm going to go through this a bit quicker for the other ones. For A3, so I'll just write AN equals A1 plus N minus 1D. Okay, for A3 we said is 0 plus 3 minus 1 times 5, which is 10. Now let's do A4. A4 is 0 again, because that's the first term. 4 minus 1 times 5, which is 15. A5, which is 0 plus 5 minus 1 times 5, which is 20. And then A6, 5. And then A6, which is 0 plus 6 minus 1 times 5, which is 25. That's it. Just a formula. Wallah, it's just a formula. Question 3. B is an arithmetic progression with the first term 8 and the constant difference minus 2. Find B5, B10, B21. Same thing. Bn equals B1 plus n minus 1 d. If you're getting confused between B and A, bro, the letter doesn't matter. It doesn't matter. Put AN, CN, ZN, XN. It doesn't matter. So in this case, B5 is going to be B1, which is 8, plus n minus 1, so 5 minus 1 times minus 2. That's the constant difference. And you should get 0. Is it 0? Yes. 8 minus 8, 0. B10 is going to be B1, again, 8 plus 10 minus 1 times minus 2, and you should get minus 10. Then B21 is again A1, which is 8, or B1, sorry, not A1, plus 21 minus 1 times minus 2, and you get minus 32. Very easy. Question 4. Find the sum of the first 40 terms of an arithmetic progression with the first term equal to 6 and the second term equal to 16. Okay, so we want the sum of the first 40 terms. The sum of 40 is going to be, it's n over 2 times a1 plus an, right? So in this case, I substitute again. As sum of 40 is going to be 40 over 2 times a1, which is the first term, 6, plus an, which is a40. Here's the thing, we don't know what a40 is, right? So can we find a40? Of course we can. A40 equals, remember the formula we've been just using, a1, which is 6, plus n minus 1d, so 40 minus 1 times d. We don't have the constant difference, but we can easily find it. 16 minus 6 is 10. For 6 plus 39d, because 40 minus 1. So d, we said 10. We said 10, not d. Because we found the d is 10. 40 minus 1 is 39, so 39 times d, and d is 10, so 39 times 10. Whatever. A40 equals 6 plus 39 times 10, 6 plus 390. A40 is 396. Okay, let's clean this up a bit. It's going to be 20, because 40 over 2, times 6 plus 396, and you get, whoa, yeah, you get 8040. Question 5. Evaluate the arithmetic series, whatever, plus to 89. Okay. So here we're actually adding. If you can see, we're using the sum. So we can use the formula Sn equals n over 2 a1 plus an. In this case, we're finding the sum from the first number to the 289. So we know what a1 is, and we know what an is. So we can substitute them, since a1 is the first one, which is minus 5, and an is the last number we're ending at, which is 289. What's left here? We're missing one thing. That's the n over 2 part. So we need this n. Okay. So we need to figure out at what place is this 289. Okay, I think it's very, very easy to figure out. You know that any number an equals a1 plus n minus 1 And we know a1 is minus 5. We know that the constant difference in this case is 6, because 1 minus 5. But we don't know what this n is, right? So we have to keep it as n minus 1 here. So this is 6 here. And we know that this an, this number, is actually 289, because the number is 289. But the only thing we're actually trying to figure out is in what position in the sequence is this 289 in. We can simplify this. 6 times n is 6n, and 6 times minus 1 is minus 6, and you still have this minus 5 equals 289. Minus 6 minus 5 to the other side, you get 6n equals 300, and you get n equals 50. This 289 is actually the 50th value. So this n, we can replace it by 50 over 2 times minus 5 plus 289, and you should get 7,100. Let me do it. Yeah, 7,100. Question 6. It's a lot of formulas, but really you just have to bear with me. Sarah started working in 1990 with a monthly salary of 1,200. Each year, her monthly salary increased by 120. Sarah's monthly salary increased by something from 2000 to 2010. So we're basically asked to find the difference between 2010 and 2000. So actually here, uh, there's 10 years between them. Let's say, let's think of it like this. We're talking about years. A of 2010 minus A of 2000 equals, uh, 2010 minus 2000 d. Why am I saying this? Because you had the formula. A of n minus A of m equals n minus m d. Using these numbers will work, because uh, you're gonna be left with A 2010 minus A 2000 equals 10d, and you just need to know what d is. And d is actually 120. Why is it 120? Because let's say you have at year 1, we call it x1, and then you have x2, and then you have x3. What's the difference between these numbers? What's changing? It's actually increasing by 120. For the constant difference is 120. It's just to help you understand. So A 2010 minus A 2000 is actually 120 times 10, which is 1200. Why am I saying minus? Because I'm trying to see and know what changed. What's the difference? So it's 1200. One thing I'm not sure of is if you're allowed to put 2010 here, or you have to put A20 minus A10. Why? Because we're actually starting at, let me show you. But let me erase this. We're actually starting at 1990. Let me put this here. We're starting at 1990. It would be wrong to say that this is the 2000th value if you're starting at 1990, because there's only 10 years in between 1990 and 2000. You could say, and there's 20 years, by the way, in between 2010 and 1990. It's the same as saying A20 minus A10, and you'd still end up with the same answer, of course. Uh, Over here, you'd get the same answer. Solving on computer, it wouldn't matter. But in written part, maybe they deduct marks for it. Maybe. I'm not saying they will, but it's because honestly, saying 2010 minus 2000 what doesn't make sense, because in the sequence that isn't the 2010th value or the 2000th value. It's actually the 20th value and the 10th value, since you're taking 1990 as your starting point. المهم, and I'm talking a lot for one question. Let me move on. Question 7. Okay. This one. It's easy, but again, formula. Okay, sigma 5k minus 2. And like the previous quiz, split up your sigma. So it's the same as saying sigma 5k minus sigma 2 up until n, right? Okay, remember, and I told you for the constant numbers, not for the k's and stuff. For the constant numbers, whenever you have sigma 2, it's always the answer is 2 times the number up. So in this case, it's minus 2n. That's only if you're starting from 1, right? But if you had مثلا sigma 3 to 7 of 2, then it wouldn't be 2 times 7, it would be 2 times, remember, 7 minus 3 plus 1. Remember the rule I gave you, which is 2 times 7 minus 3, 4 plus 1, 2 times 5. So you'd get 10. In this case, it's 10. But in this case, we're starting at 1. All's well, all's good if you just multiply 2 times n. So minus 2n. So you're going to be left with sigma 5k up until n from I equals 1 minus 2n. We need to simplify this. Okay, sigma 5k is the same as 5 sigma k up until n starting from I equals 1 minus 2n. Okay, what is sigma k? I gave it to you at the start. It's the same as saying the sum of any number up until n, up until infinity. I told you it's actually n over 2 n plus 1 minus 2n, obviously. This was the rule. Remember, I wrote it here. Sigma k is n over 2 n plus 1. So now all you have to do is just simplify. Let's start by simplifying this. N over 2 times n is actually n squared over 2. N over 2 times 1 is just n over 2. And you still have that 5 outside. Let's minus 2n. Let's continue simplifying. Let me take this up. 5 times n squared over 2 is actually 5n squared over 2. And 5 times n over 2 is 5n over 2 minus 2n. Obviously, obviously we have to make the same denominator, right? For minus 2n, we have to multiply by 2 up and down to make it same denominator. So it will be 5n squared over 2 plus 5n over 2 minus 4n over 2. Simplify this more, take this up. 5n squared, you can't simplify it. 5n minus 4n is just plus n over 2. Okay, but they want you to put it not as a fraction, as a decimal. For 5n squared over 2, 5 divided by 2 is 2.5 n squared, and then n over 2 is same, it's like 1 n over 2 is the same as saying 0.5 n, because it's half n, so 0.5 n. It's a bit long, but saying it is what it is. Here, 3 plus 8 plus 13, same thing. They want you to evaluate the sum. It's a sum. So we have to use the formula Sn equals n over 2 a1 plus an. We know what a1 is, 3, and we know what an is, so 3 plus 503 times n over 2. What's the problem? We don't know where 503 is placed. What value is it? So we have to use the formula an equals a1 plus n minus 1 d. An, which we know is 503, equals the first number, which is 3, plus n minus 1, we don't know it. The difference, we do know it, it's 5, because 8 minus 3. Yeah. Okay, distribute this 5 as we did last time. It will be 5n minus 5 plus 3 left over equals 503. 5n minus 5. Take minus 5 and 3 to the other side. It becomes 505. So n equals 101. So now we know this n is 101. Let's go back to our equation here. We know n is 101. It's going to be 101 over 2 times 3 plus 503. And you should get 25,553. Question 8. Let A be an arithmetic progression with first term minus 12 and common difference 6. Let B be another arithmetic progression with first term 5 and common difference 5. Is there a value of k which AK equals BK? So look here. We want AK to be equal to BK. And to do that, you need to know the rules for both AK and BK. And if you remember from the first one, the simplest way you can write any sequence is an equals an plus, oh, not an, sorry, un, sorry, un equals an plus b. A number multiplied by n, which is usually the constant difference, plus b. If you remember, this was from the first recording 6.1. So we need to equate the rule of a, sorry, to the rule of b, and we're gonna get a number. That's when, and no, you can say both of these sequences are equal to each other. Let's look at the progression A. Let's look at sequence A. The first term is minus 12, and the common difference is 6. We know already that an equals, the common difference is 6, for 6n plus b. We don't know what this b is, but we know that the first term is minus 12. So what can you say? Minus 12, it's a1, right? a1, the first term, minus 12, equals 6 times n, which is 1, because we're still talking about the first term, plus b. How, how would you find b? You take 6 to the other side. B is minus 18. For the rule for an is actually 6n minus 18. How about sequence B? Sequence B, bn, is equal to the common difference, 5. So 5n plus b. How would you find b? Same thing. They gave us the first term is 5. For bn, which is 5, it's the first term, equals 5 times 1 plus b. 1 because it's the first term. 5 to the other side, and you get b equals 0. For bn is just 5n plus 0. No need to write the 0. We want to equate ak and bk. Let's equate 6n minus 18 to 5n. 6n minus 18 equals 5n. Take 5n to the left, 18 to the right. You get n equals 18. So at n equals 18, both of these sequences are equal. Question 9. Again, same thing. I'll go through it a bit quicker. Since we're talking about the sum, it's n over 2, a1, which is 3, plus an, which is 63. Okay, but what's the problem? We need to know n. We need to find out 63. What is it? We know that an equals, any an equals a1 plus n minus 1 d. An is 63, a1 is 3, plus n minus 1 times the constant difference, which is 4. Distribute this 4, you're gonna get 4n. You'll get 4, yeah, 4n minus 4. 4 times n is 4n. 4 times minus 1 is minus 4. And you still have that plus 3 equals 63. Minus 4 plus 3, it becomes 4n equals 64. N equals 16. So we can go back here and we can put n as 16 over 2, 3 plus 63. Equate this on a calculator, you get 528. How many questions is this quiz? 13. Okay, question 10. What's the value of the common difference of the arithmetic progression? How do you, like, okay, sure. Well, common difference, 5 minus 2. 7. That's it. Question 11. What's the value of the 31st term of an arithmetic progression if the first term is 6 and the common difference is 10? Any an equals the first term, a1 plus n minus 1 d. So if we're talking about the 31st, for a31 equals a1, which is 6, plus n minus 1 for 31 minus 1 times the common difference 10. For a31 is going to be equal to 6 plus 30 times 10. For a31 is 306. Question 12. What's the sum of the first 18 terms of an arithmetic progression if the first term is 8 and the common difference is 2, blah, 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 blah. So the sum of 18 terms is equal to n over 2, a1 plus an. Okay. Sum of the 18, yani n over 2 is going to be 18 over 2 because n over 2. a1 is 8 because it's the first term. But do we have an? We don't. As the a18, we don't have the 18th term. But they gave us that the common difference is 3. Can you find a18? Of course we can. An equals the first term plus n minus 1 for 18 minus 1 times d. Let's simplify this a bit. A18 equals a1, which is 8 because it's the first term. 18 minus 1 is n minus 1. And then d is 3 for 8 plus 17 times 3, which is 8 plus 51, 8 plus 59, 59 I think. 17 times 3 plus 8, yeah, 59. So A18 is 59. We can go back here and we can put 18 over 2, 8 plus 59. Yeah, plus 8 times 9. Yeah, and you put this in a calculator, you get 603. Question 13. How long is this recording? Oh, okay. What is the value? Okay, look. One rule I should give. One rule I should give. If A, B, and C are consecutive terms of an AP, oh, of an AP. AP standing for arithmetic progression. B is going to be A plus C over 2, and it's actually called the arithmetic mean, because they might ask it. What is the arithmetic mean of this sequence? It's A plus C over 2. So 10 plus 52 divided by 2, and you get 31. Okay, because since y is in between them, that's the mean. Okay, that's it for 6.2. Thank you for watching. Good luck.